Did you know that if you have the percent volume of a solution that you bought at the store, you can calculate how much solute and solvent you have? Solutions and concentrations. So a concentration is the ratio of the quantity of solute to the quantity of the solution. So we can have a dilute or concentrated solution. Products sold in stores are often sold as concentrated because that way they have the product weigh less and is cheaper to package and ship. And then you will dilute the product once you reach it at home. A saturated solution is considered saturated when it cannot have any more solute dissolved into it. So if we have an unsaturated solution containing 30 grams of sodium chloride or salt in 100 milliliters of water, it means we could add more salt. However, if we added 40 grams of salt to 100 milliliters of water, the solution became saturated at 36 grams of sodium chloride. So the additional 4 grams of sodium chloride remained undissolved. So you can see this if you add salt to water. At one point, you can't stir it to dissolve the salt anymore, and that salt will just remain in the solid form. So concentrations can be observed using the 5 sentences. So we can have a darker, a stronger smell, or a thicker in texture solution. Quantitatively, we can use values and measurements, and we can call them 5% weight per volume, 5 grams per liter, 5 parts per million, or 5 moles per liter. So we can quantitatively measure the concentration of different solutions. Now, when the concentration of the substance is specified, it describes the amount of solute per amount of solution. So this is what has been dissolved into the solvent. To increase the concentration of a solution, we could either add more solvent. So if you were making homemade iced tea and you're like, oh, that's not strong enough, what you do is you add more iced tea powder. And this is usually the first solution because it's easier. You could also remove some of the solvent, but this is very difficult. To do that, if you want to make your iced tea stronger, you're going to have to put it onto the stove or microwave, bring it to a boil, and allow some of the water to evaporate. To decrease the concentration of a solution, you can either remove some solute or add more solvent. Now, this is usually done, so let's imagine we made our iced tea and we made it way too strong. So our solution is going to be to add more water to bring it to a more dilute concentration. So looking at the collision reaction theory, this theory says that reactions take place because molecules collide with one another. These collisions cause bonds to break, and the reattachment of particles can form new compounds. The more collisions that occur in a reaction, the faster that reaction is going to occur. So more concentrated solutions, because they have more particles, are likely to have more collisions and then a faster reaction occurring. Heating a solution, which adds energy, makes the particles move faster, increasing the speed at which they could collide, speeding up the reaction. So more concentrated solutions and heated up solutions are more likely to have a faster reaction. So a more concentrated solution will likely be a stronger electrolyte and produce a higher reading on a conductivity meter and behave more quickly in a reaction due to the increased amount of solute particles. So one of the ways we can calculate concentration is by looking at the molar concentration. This is how many moles of the solute per liter of the solution that there are. Now, the unit for molar concentration is moles per liter. And we assume that the volume of the solvent is equal to the volume of the solution. So if we add 100 grams of salt to 1 liter of water, we get 1 liter of solution. The salt does not significantly alter the volume of the solution. So the volume of our solvent is our total volume. So remembering the mole from Science 10, the mole is a standard unit amount of a chemical substance. Just as a dozen is 12, a mole is 6.02 times 10 to the 23rd molecules. So it makes us possible for us to calculate the amount of a substance or to compare different elements because single atoms are far too small to see and measure. So every element on the periodic table has its own atomic mass, and the molar mass is the mass of an element in grams per mole of that substance. So different elements have different molar masses, which means the weight of 1 mole will be different for those elements. So the molar mass of carbon is 12.01 grams per mole. This means that 1 mole of carbon weighs 12.01 grams. This will be different than oxygen that weighs 16.00 grams. There's where we find the molar mass on our elements on our periodic table. Molar mass of compounds can be calculated by adding up the molar mass of its composing elements. So we can calculate the molar mass of water by writing its chemical formula, H2O. So we're going to take 2 times the molar mass of hydrogen plus 1 times the molar mass of oxygen. So we have 2 atoms at 1.008 and 1 atom at 15.999. So the molar mass of water is 18.015 grams per mole. Now sometimes this will calculate to 18.02 grams per mole because oxygen has been rounded up to just 2 decimal places, and same with hydrogen. So again, from Science 10, recall the formula for mass moles equals mass over molar mass, and we can rearrange this to solve for mass and to solve for molar mass. So to solve for mass, we will have mass. My pen's not working right now. Mass is equal to moles times molar mass, and I'll make that one really big so we can see. And then molar mass is equal to mass divided by moles. So those are the 2 rearrangings of the moles formula. So I hope you enjoyed today's lesson. See you next time. Bye.
If you enjoyed this video, check out our website, online.plrd.ab.ca, and visit us on Facebook, Prairieland Online Academy. You can find out all that's going on with Prairieland Online Academy.